Okay, so this next assignment, before Friday's quiz, will be to, do the same thing basically, but you won't be given all the blue stuff, the help. Okay, so you try to, do as much as you can, just from memory. Yeah, okay, so let me get situated. All right, so my advice is still the same, is to fill this out, then graph, and then do domain and range. Okay, so for this one, is a constant function. So the y-intercept is always 0 comma something. In this case, it's just 0 comma 3. Let me get this black. 0 comma 3. Actually, no. It's blue. Okay, slope for constant functions is always 0. All right, and then we go over and graph it. So this is just a horizontal line at y equals 3. Okay, domain, you can see this goes to the left forever and then goes to the right forever. Okay, and then the range, this only goes through, as far as y values, it only goes through 3. There's only one number in the range, and that's 3, so you have to put it in the squiggly brackets. Okay, parentheses and brackets, regular brackets, are for, kind of all the numbers from this to this. Squiggly brackets is just for a single number. You can also list them, but for us it'll just be a single number. Okay, next one. Okay, X-Intercept. So I'll start out this way. X-intercept is always something comma 0. Y-intercept is always 0 comma something, like that. Okay, so let's say you forget. You can always set this equal to 0 and solve. Yeah, so, but it's always, if you remember, this first part is negative b over m. And so for this one, this would be negative, b is 8, m is negative 4. The two negatives cancel, and then this is just 2. The x-intercept is 2. And you can see if you plug in 2 for x here, this whole thing equals 0. Okay, y-intercept is always 0 comma b, and you could also plug in 0 for x and see that you're just left with 8. So that's it. Okay, slope is just m, whatever is multiplied by x, so negative 4. And then we graph. Okay, so x-intercept is 2, so we'll plot these points. Y-intercept 0 comma 8. And then just draw this line through it. Okay, domain and range are both negative infinity to positive infinity for this function always. All right, this goes left forever, right forever, down forever, up forever. So, okay, next one. Now we get into the whole HK thing. In this case, remember h is the opposite of whatever's with x. So here's h is a positive 1. K is the same as the thing that's added on the outside, so that's 4. So our vertex for absolute value functions, vertex is h comma k. Okay, this will be facing down because there's a negative out front. Okay, 2 additional points. So that'll be h plus 1 and h minus 1. Since h is 1, h minus 1 is 0, and h plus 1 is 2. And then we plug those in. Okay, plug in 0, negative 3, absolute value 0 minus 1. plus 4. Okay, so this 0 minus 1 is negative 1, but the absolute value of negative 1 is positive 1. So this is negative 3 times positive 1 plus 4. And then negative 3 times 1 is just negative 3. And then plus 4 is 1. Okay, so now we'll plug in 2. Okay, so this is the same thing. 2 minus 1 is 1. Absolute value of 1 is 1. Negative 3 times 1. Okay, and you should always get the same y coordinate when you do when you plug in h plus 1 and h minus 1. You should get the same y coordinate. Okay, so let's plot. We got 3 points to plot: the vertex and the 2 additional points. So 1, 4, 0, 1, 2, 1. Okay, we know the general shape for absolute value is a V starting from the vertex. Kind of goes like this and like this. Okay, domain. You can memorize for absolute value, domain's always negative infinity to positive infinity. Or you could look at the graph and see that this goes left forever and goes right forever. So that's negative infinity to positive infinity. Okay, for range, so you look how far down does it go? It goes down forever. That's negative infinity. And it doesn't go up forever. It stops when y is at y equals 4. And so the range is always, or the range here is negative infinity up to 4. And then since there's a point here and there's no asymptote, since there's a point, there'll be a bracket. Okay, next ones. Okay, actually, so h and k, let's get that. So h is a positive 2, k is a negative 6. So the vertex is h comma k, which is 2 comma negative 6. Okay, this is going to be facing up because there's no negative out front. Okay, 2 additional points just like the previous one. 2 additional points will be h minus 1 and h plus 1. Since h is 2, h minus 1 is 1 and 3 for h plus 1. And then we plug those in. Actually, I'm going to start using a different color to make this better. Plug in 1 into that function up there. 1 minus 2 squared. Okay, and then we'll also plug in 3 into the function. We'll just do them like this. Okay, for the top one, 1 minus 2 is negative 1, and negative 1 squared is 1. And then we still have that minus 6. And 1 minus 6 is negative 5. Okay, for the other one, 3 minus 2 is 1. 1 squared, again, is 1. Minus 6 is negative 5 again. Okay, plug in 1, you get negative 5. Plug in 3, you get negative 5. Okay, so this is just like absolute value. For the 2 additional points, if you plug in h plus 1 and h minus 1, then you'll always get the same y value. Okay, so let's graph it, and then we'll do domain and range. Okay, so vertex and the 2 additional points. Okay, vertex is at 2, negative 6. And then 1 comma negative 5. 3 comma negative 5. Okay, and then just remember for quadratics, the general shape is curvy, like a U. Okay, domain quadratic is always negative infinity to positive infinity, and you can look at the graph to see it goes left forever and goes right forever. Okay, range, how far down does it go? So it doesn't go down forever. The lowest it goes is to negative 6, and there's a point there, so we'll put bracket negative 6. And how far up does it go? It goes up forever, so that's infinity. Okay, next one, cubic function. So in this case, h is negative 5, k is 0, since there's nothing added on the outside. Okay, middle point for a cubic function is h comma k, so negative 5 comma 0. Okay, 2 additional points, same as the last couple. We'll plug in h minus 1 and h plus 1. So let's do that. F of negative 6 and f of negative 4. Okay, f of negative 6 is negative 3, 6 plus 5 cubed, and negative 4. Let's do these. Okay, this first one, negative 3 times. Okay, so this whole thing, so negative 6 plus 5 is negative 1, and negative 1 cubed is still negative 1. Okay, negative times a negative is a positive, so this will be positive 3. 3 times 1. Okay, for the next one, inside here, negative 4 plus 5 is 1. 1 cubed is still 1. So this is negative 3 times positive 1, and that's negative 3. Okay, plug in negative 6, you get 3. Plug in negative 4, you get negative 3. Okay, so let's plot these. Negative 6, 3, negative 4, negative 3. Okay, so they're all in a line like they should be, but we got to memorize the graph. So the graph is not a straight line. It's like curvy from this middle point. Kind of curves one way and goes down really quick, and then curves the other way and goes up really quick, like that. Okay, so domain and range for this one are both negative infinity to positive infinity. Okay, this function goes left and right forever and goes up and down forever. Okay, next one, h is 4, k is 6. Okay, the endpoint is hk, so 4 comma 6. Okay, 2 additional points. We'll plug in, this one's kind of different. We'll plug in h plus 1 and h plus 4. You can remember it like 1 squared is 1, 2 squared is 4. Right, so just plug in, just add 1 squared and 2 squared to the square root function for h. Okay, so h is 4, so h plus 1 is 5, and then h is 4, so h plus 4 is 8. Okay, so plug these in. Oops. Okay, so it's 2 square root. And here I'm going to plug 8 into the bottom one, and then we'll simplify both. this is 2 times, and then this square root, so 5 minus 4 is 1, square root of 1 is 1, so this is 2, whoops, 2 times 1 plus 6, and that's just 8. Okay, next one, 2, and then the square root of 8 minus 4, so 8 minus 4 is 4, square root of 4 is 2. Okay, 2 times 2 is 4, plus 6 is 10. Okay, so plug in 5, you get 8. Plug in 8, you get 10. Okay, so let's plot these points, 4, 6, 5, 8. 8, 10. Okay, keep in mind this is the end point here, so it's got to go off through these points, and then we know the general shape, it kind of keeps curving off. Okay, so that's good for that. Okay, next one is rational function. Okay, vertical asymptote is x equals, actually let's get h and k first. So in this case, h is -4, the opposite of whatever's with x. And then k is -3, the thing subtracted on the outside. Okay, so the vertical asymptote is always x equals h. That's x equals -4. Horizontal asymptote is y equals k. Y equals -3. Okay, so 2 additional points. So you plug in h minus 1 and h plus 1. So since h is -4, plug in -5 and -3. Okay, so let's do that. Okay, so that's going to be 2 over -5 plus 4, 3. And the other one will be 2 over -3. Okay. Okay, so the first one, do the bottom first. -5 plus 4 is -1. 2 divided by -1 is just -2. And then -2 minus 3 is -5. For the bottom one, -3 plus 4 is a +1. 2 divided by 1 is 2. And then 2 minus 3 is -1. Okay, so plug in -5, you get -5. Plug in -3, you get -1. Okay, so let's do asymptotes first. So x equals -4. And then y equals -3. Okay, we'll plot the 2 points, -5, -5, -3, -1. Okay, and then we just have to know the general shape. You know, the graph goes through these points. So here it'll go towards this asymptote and then go up towards the other asymptote. Okay, same thing with this point. Go now up towards this asymptote, closer and closer, and then down and closer to this asymptote as it goes. Okay, next one, exponential function. h equals +1, k equals -7, okay, and then a, thing multiplied out front, is 3. Okay, horizontal asymptote horizontal asymptotes are always y equals something. So for this one, it'll be y equals k. So y equals -7. Okay, turning point is h comma a plus k. So 1 comma a plus k is 3 plus -7, which is -4. Okay, and just so you know, you could remember, one thing you could do if you're having trouble memorizing stuff, you could just remember that the turning point is h comma something, and then just plug in 1 for x. So here you know h is 1, and then you could just plug in 1 into this, and you'll get 3 plus -7. You'll end up, it'll simplify to that. So you don't have to memorize all this stuff if you have a tough time memorizing. Just you could kind of learn how to do it a little bit more. Okay, so 2 additional points, h plus 1 and h plus 2. So h plus 1 is 2, h plus 2 is 3. Plug these in. Plug in 2, so we, oops. We get 3 times 2 to the 2 minus 1 minus 7. Okay, this will be 3 times, okay, so 2 minus 1 is 1, 2 to the 1, so we have to apply this exponent to 2 first. So be careful, you don't want to do 3 times 2. You have to do the exponent first. So 2 to the 1 is just 2. Okay, then, order of operations, PEMDAS. After exponents, you do multiplication. So 3 times 2 is 6. Minus 7 is -1. Do the same thing, plug in 3. Okay, this will be 3 times, okay, 3 minus 1 is 2. 2 squared is 4. 3 times 4 minus 7. 3 times 4 is 12. Minus 7 is 5. Okay, so you plug in 2, you get -1. So that's a point. Plug in 3, you get 5, so that's the other point. Okay, so let's do the asymptote first, maybe. So y equals -7. Oops. Okay, and we'll plot these 3 points. Turning point is 1 comma -4. Additional points 2 comma -1 and 3 comma 5, and then we just graph it. So from the turning point, it goes up really fast through those points, and then it goes down really slowly towards the asymptote. Okay, last one, log function. Okay, so for this one, h is 3 and k is 6, and we'll need b, the base. Base for this one is 2. Okay, vertical asymptote is always x equals h, so this will be x equals 3. Okay, turning point, and I kept making that mistake. Turning point's h plus 1 comma k. So since h is 3, h plus 1 is 4, comma k is 6. Okay, and then for the two additional points, we'll plug in h plus b and then h plus b squared. So you can see h plus b, 3 plus 2 is 5. Okay, and since b squared is 4, 3 plus b squared is 3 plus 4, so that's 7. Okay, so we'll plug those in. Okay, plug in 5. And then here I'll plug in 7 then. Alright, so 5 minus 3 is 2, and then log base 2 of 2 is 1. So this just simplifies to 2 times 1 plus 6. Okay, just see clearly, this whole thing is just 1. So everything else stayed the same. Okay, 2 times 1, so I have to do the multiplication first. 2 times 1 is 2, plus 6 is 8. Okay, next one, let's evaluate this log first. So 7 minus 3 is 4. Log base 2 of 4 is 2. That's 2 times 2 plus 6. And 2 times 2 is 4, plus 6 is 10. Was that the same as... Oh, that's weird. Okay, so you plug in 5, you get 8. Plug in 7, you get 10. Okay, so let's do the asymptote. X equals 3. Okay, the turning point, 4 comma 6. Additional points, 5 comma 8. 5 comma 8. And 7 comma 10. Okay, so here's our turning point. From there, it'll go through the points and then kind of taper off. And then to the left of the turning point, it just keeps getting closer and closer to the asymptote forever. Something like that. All right. Okay, so the actual quiz will look a lot like this. The only difference is for the actual quiz, here I'll show you, you won't be given this general form here, and then they'll be mixed up in different orders. That's the only difference. So okay, but people's work looks good. And yeah, if you have any questions today, just let me know.